Turn on camera, everyone. Like you should be visible. Like you will be studying there. Your notebooks, your pen should be visible. Not like that. You are roaming here and there on road. Okay, so keep your camera turned on.
Sir,
Put your
telling me on the
No, no. If you are turning on your camera, you are keeping your camera turned on, then no problem. If you are outside also, then it's okay. Right? Just put your camera in front of your notebook or anywhere you can just put your camera. Just keep writing and keep asking your questions. Keep writing. Yes. Yogita and Lexida also.
So my camera is something problem, sir.
What type of problem?
Can
You can just no problem. You can turn on your camera.
I just turned on, but it's not turned on in my video. It's not visually.
You just denied the notification. Okay. So right, go to setting and just search Zoom meeting and there will be an option for permissions. Give permission to your camera. Then camera will be on. Lakshida. But the identities are okay. See, if you are sitting in a silent room, you can turn on your mic also. Like no need to turn on, turn off mic while speaking. So these properties are okay, fine. You are writing each and every property. Are you writing these properties? All these property? Arun?
Yes, sir, I'm writing.
See, in place of question number 10, in place of this A, in place of this A, put C. Then you will get answer in terms of X only. Okay. As you can see here, C to the base C, this will be become 1. This will be 1.
Wherever A comes, I need to put a C, sir. C as a
Just take here C. Okay, then you will get answer. Right. So just write down first of all the property. Okay, then we will be solving all the problems. This property 9 is very, very important. Okay, we will be using for advanced to solve advanced questions. Like if any number is given in place of that number, you can write down that number with log. This property 9. Like 2 also with you can write down like this. Like 6 raised to log of 2 to the base 6. You can write down like this also. Right. 12 also
So
can
for
be this number.
for 10th question, I'm getting x by x minus 1.
Yes, correct.
I'm sorry, 9th question.
No, question number 10, I think. Okay, okay, yes,
For
9. Question number
10th,
9.
1
Question
minus.
number 9, yes, yes, yes. 10th we already solved.
For 8th question, b is equal to 5, sir.
Okay, okay. Right on property number 11, I think. Yes, property number. This is not property. This was the question.
It's
Right on
property
property
tax.
number 10. Right. What is property number 10? So property number 10, you can write down any number. If any number is written with log like this, a raised to power a raised to log of c to the base a, right? So this you can write down c. And again, sub part of this property, if any number is written log of a raised to log of c to the base b, if base is different, right? So what you can do, you can interchange a with c. Always you can interchange a with c, like c raised to log of a to the base b. See, this is like this one, a, here it is b, here it is c. So you can interchange a and c every time. You can just rotate by holding at b, you can just rotate it. Right? This property is also important. Right? You see, property. Just take one example. Log of x to the base 2 plus log of x minus 2 to the base 2 is equals to 2. Okay, just solve this. Find the value of x. Try to solve this equation. So every time you have to keep in mind, see, these properties are like arrows, like bow and arrows. So you have to keep this ready with yourself. If it looks like any question, just ready your arrow with bow and just run it. So there are three most important conditions for log. One is base should be greater than 0, base cannot be equals to 0, and argument should be greater than 0. These very important. These are called Brahmastra, right? So by using these three properties, you will solve the questions. Every time, if you are using any property, like if you are using product rule of log, first of all, log should be defined, right? So if you are writing this as log of x into x minus 2, this is okay. But while taking product, first of all, log should be defined. Then we can multiply both things. Like just see here. What are the sign of these expressions? So root is 0, one root is 2. So this side it is positive, negative, and positive. Right?
1 plus root 5.
What is it? What's it out?
X value 1 plus root 5.
Root 5.
Yes, sir.
Answer is
1 plus root 5.
1 plus root 5. Okay. So not 1 plus minus root 5. Only 1 plus root 5 is the answer.
Yes, sir. Not minus.
Yes, correct. See, yes, answer is correct. Just see here. So as you can see here, if I put in place of this x, if I take here x equals to like -2, if I put here -2 in this log, if I put -2, so we will get -2 into -2 into -2. So this is equals to log 2 to 4, 4 to the 8, right? You will get log 8, right? So log 8 is defined or not with the same base as 2. Log of 8 to the base 2 is defined or not? Just tell me this.
Yes, sir. 3.
Log 8 is defined. Log 8 means argument is positive, base is positive. Yes, it is defined. But as you can see here, just see here. If I write down, just take a note here also. Log of 2 plus log of x minus 2 to the base 2 is not equals to log of x times x minus 2. This is not always equal, right? What is the reason?
Why, sir?
What is the reason?
Base is not defined, sir.
Reason is we can multiply the log if both are defined, right? If we are multiplying log, then we have to first of all define the logs, then we can multiply. So when this log x is defined, when x is greater than 0, as you know, base is already given 2, that is greater than 0. If x is greater than 0, then log x will be defined. Log is not defined for negative numbers, right? Again, what when this log is defined? When this log is defined, log of x minus 2, when x minus 2 is a positive number, right? As you know, there was 3 conditions: a greater than 0, b greater than 0, and b cannot be equals to 1. These 3 conditions were there, right? So based on these 3 conditions, x minus 2 should be greater than 0. As you know, base is already positive given here, so no need to take that condition. So x greater than should be 0, x should be greater than 0, x minus 2 should be greater than 0, right? So x should be greater than 2. Here x should be greater than 0. So both should be true. So if we are considering these 2 conditions, right, then we can write down this log x to the base 2 plus log x minus 2 to the base 2 is equals to log of x into x minus 2. Then it will be true. Why these 2 equations are not equal? So first answer is their domains are different, right? So the first answer is why these are not equal. So the first answer is domain of these 2 expressions are different than this expression. Domain of log x minus 2 will be not same as domain of log x plus log x minus 2. Domain of these expression is, as you can see, just take intersection here. So you will get 2 to infinity, not open. Domain is 2 to infinity for this left hand side expression. And domain of right hand side expression will be minus infinity to 0 union 2 to infinity. As you can see this sign method. This side it is positive here, this expression. This x into x minus c. See the sign convention. So this x into x minus 2 is positive between minus infinity to 0. It is positive minus infinity 2 to infinity, right? So log is defined for positive numbers. So this log is defined for these numbers. And this left hand side, whatever expression is there, that is defined only for 2 to infinity. That's why both expressions are not same, right? So at the time of multiplication, we have to restrict the expression. If x belongs to only 2 to infinity, then we can multiply. We can write down log of x plus log of x minus 2 as log of x into x minus 2. Got it?
Yes, sir.
I think I have over explained here. But you should understand this. Now, so now we will solve this expression. So log of x into x minus 2 to the base 2, it is equals to 2. This was the question. Now you can write this is base raised to this value of the log. This is equals to x into x minus 2. So now this is 4 equals to x square minus 2x. So x square minus 2x minus 4 equals to 0. So here you will get two answers. X is equals to 2 plus minus 2 2s are 4 4 4 4s are 16 divided by 2. So here you will get 2 plus minus 2 root 5 divided by 2. So you will get 1 plus minus root 5, right? So there are two values of x, 1 minus root 5 and 1 plus root 5. As you can see, this number, this x is not lying in this interval 2 to infinity, right? That's why only the answer is x equals to, this is rejected and this will be the answer. So x is equals to 1 plus root 5 only. Only this answer is correct, right? But again, if you don't know about how to solve these type of inequality, then you will get two answers. X equals to 1 minus root 5 and x equals to 1 plus root 5. Okay, so only this answer is correct because we have to take intersection. We have to take intersection with this value of x and with this value of x. So after taking intersection, you will get answer as 1 plus root 5. Any doubt? So before using the properties, first of all, you have to define the roots. Okay. If root is defined, then you can use the property. Okay. So again, write down. This was the first I think what is the number of property? Okay. So in the property first, this was the put here first part of property 10. Okay. Or also you can just consider it separate property. Or just write down property number 11 and first part. First part is log of b to the base a plus log of c to the base a is only equals to log of bc by b. This is only equals if this is defined and this log is also defined. Then only we can use this rule, product rule. Got it? Arun? Tirumalai?
Yes, sir.
Tirumalai?
Sir,
Property, sir.
Yeah, what? Arun?
can you show the property 8 and 9, sir?
Property 8 and 9.
Yes, sir. From
Property
here,
8, base changing formula. Property 8 is base changing formula.
property 7, sir.
Property 7 is log of b upon c to the base a equals to log of b minus log of c to the base a. Right? Any rational form is given, so you can break it into difference. B upon c, you can write on log of b minus log of c. Okay. Log b by c can be written as log b minus log c. Okay. Okay. So property 11 is this product rule. Okay. You want to write on more properties like property 9 also?
Yes.
Property 9. Any positive number can be written in this form.
Okay.
Hmm. Property 10 is also important, very, very important. This thing, very, very important. Right?
So can you please show those examples of dominance, sir?
What? Examples?
Yeah, nothing, sir. I got it, sir. This one only. I was checking it was right and I got it. Yes, sir, done, sir. You can move.
Property number 11. This is first part of property number 11. Second part. This property 11 is what is allowed and what is not allowed. And if it is not allowed, then what you have to do. Right? So this was first illustration. Same for division rule also. Log of b upon c to the base a. Right? This can be written as log of b to the base a minus log of c to the base a, when only both log of b, log of c, both should be defined. Then only you can break into this difference way. Right? Then you can create the difference from division. Like log b upon c only can be written as log of b minus log of c when both b and c, right, these should be defined. Okay. So both, only you can write down this if both LHS and RHS are defined. Then only you can break into any division quotient rule. You can, this is also got quotient rule. So b upon c only written by b minus c only if both are defined. LHS also should be defined. RHS also should be defined. Like LHS is defined, but while writing log of b minus log c, if log b is not defined, then it will be not valid to write down in difference form. Right? First, third. Third again, very, very, this was also very important. Log of x square, right, to the base a. This is not equals to 2 times log of x to the base a. Is this correct or not?
Why not?
See, if I write down log of 4
Sir,
square
x square
to
will
the base
always
3.
be positive, but it cannot be positive. May or may not be positive.
Yes, their domain is different, right? Here you can put negative value for x, but here you cannot put negative value for x, right? So as you know, 2 we can take it outside. So 2 times log of 4 base 3, right? But this property is only valid if this log is defined. As you know, for x log of 4 is defined. But here variable is given in the property third, variable is given. So if you are restricting the domain, then only you can put. So suppose if I am writing here log of x square to the base a is equals to 2 times log of x to the base a. If x is greater than 0, then it is valid.
Zero.
Both will be defined. So every time you have to write down, if you have to match the domain, then you have to write down log of x square to the base a equals to 2 times log of mod x Got it? This is valid. So there is no need condition. Domain for both expression will be same. Real number minus 0. X belongs to real number minus 0 because at x equals log 0 is not defined. I told in the class. Write on all these things. Fourth one. If you have any doubt, if you want more explanation for any these properties, I will explain you with the examples. Right? If you are not sure about any properties, just you need to ask. Just, sir, can you explain this once again? Can you explain? Can you give some examples? Right? I will give examples if you have any difficulty to understand any concept. Right? So fourth one. Fourth
I
property
can
is
understand, but it's not actually fitting into my mind. It's
what?
very. I mean, I can understand everything, sir, but it is not fitting into my mind. Like log is very new to me.
See, yes, sure. So if suppose if you are understanding anything, but your mind is not accepting this one, how this can be true? How this can be? So, so you have to ask that one also. Okay.
Telling like it is true but false.
Well, that's what you have to ask, sir. How this is not true? Why this is not true? So then I will explain. Just put x equals to minus 1. Just put x equals to minus 1 here. You will get x square as 1. So log 1 is 0. But can you put x equals to minus 1 here? Log of minus 1. Log of minus 1 is not defined. Right? That's why it is not same. See, what is the domain of this log? What is the domain of this log? What are the values of x which we can put here?
Real number.
Real number. But 0 again we cannot put here.
Of course.
So what about this log? This log, which value we can put here? We can
Cos of
put 0 to infinity.
minus.
Right? So these functions are not equal because their domains are different. Right? If domains are not same, then two functions cannot be equal. If domain is same, then only the two functions can be equal. Right? So that's why in the second one, I have restricted this function. Like if only x is greater than 0, then both domain for both expression will be same. Both expression will be equal. Right? So again, if you write down complete expression, right, complete information, then this is the complete information. So log of x square is equals to 2 times log of mod x to the base x. Now while putting mod x, here minus infinity to 0 also we can put. And here also we can put minus infinity to minus infinity to 0. And again we can put 0 to infinity. Right? That's why this one is correct and above first one is not correct. Second one is only correct if x is positive number. Third one is always correct. Both sides. Okay. Domains of both side, left hand side, right hand side, both have same domain. Now fourth
Yes.
is fourth property. Property number 4. So here 1 upon or also log of a to the base b. This you can write down log of 1 upon log of b to the base a. You can interchange argument with base. Right? So let's see proof also. How we can write down this. So I'm using base changing formula. So log of a to the base b can be written as log of a with another base. You can take any base. Suppose I'm taking here base same as argument, log of a to the base a. And in division, I am taking log of b to the base a. Right? This numerator, this will become 1 and this denominator will become log of b to the base a. Right? So this is the proof. Fifth one. Log of x cube to the base a. This is same as 3 times log of x to the base a. This is same because
Modulus X is it?
no need to put mod here
Oh,
because
no, no, yes, yes. Negative is allowed.
cube is here, right?
Yes, sir, yes, sir.
So as you can see,
Only
negative
for
numbers
you
are
and
not
the
allowed
first.
here. Yes, negative numbers also are not allowed here. Domain of both the expressions are same, right? Both expressions are defined for same values of x. Right? So no need to put here mod. So for sake of completion, you can just also write down log of x raised to 2m to the base a. It is always equals to 2m times log of mod x to the base x. For odd index, you can just take it outside. No problem. No need to put mod here. Both are defined for same number, same values of x. Right? Any doubt? So now there are few more properties. 2-3 properties are there. So first one is log inequalities. Okay. How we will solve inequalities in logs? Like logarithmic inequalities are given. How we are going to solve? Okay. First one. If a raised to x is greater than a raised to y, right? So there are two possibilities. One is you will get x greater than y. Both bases are same. X will be greater than y when a is greater than 1. Inequality will remain change or will remain same. Right? But only if a is greater than 0. If a is a positive number and which is greater than 0, then you can cancel out the base and just exponent you can write down with the same inequality. Right? And second condition, here
A is
x
greater
will
than
be
what it is.
less than y. When if a belongs to 0 to 1, right? It is lying between 0 to 1, then inequality will get changed. As you know, base cannot be negative, right? It will be positive and base cannot be 1. As you know, base is always greater than 0 and base cannot become 1, right? So either it will lie between 0 to 1 or it will lie 1 to infinity. There will be always two cases for log and for exponential function. For base, there will be two type of cases always for log. If base is lying between 0 to 1 or if base is lying between 1 to infinity, right? Like this. See, there will be always two cases. This is the domain for log.
Does the
This is
inequality
1.
return is
1 is not included. What?
can you repeat the above points, sir? Like
It is
why a should be greater than 1, sir?
why? Base is greater than 0.
Why a is greater than 1? A.
This a.
Huh.
Yes, see here. So let's see one example. Suppose I am taking here 5 raised to 20 and here 5 raised to 21. If 5 raised to 21, suppose just take here 22. Which one is greater?
22.
5 raised to 21, 22 is greater than 5 raised to 21,
21.
right? So here you will get inequality greater than, right? If I write down here 0.5 raised to 21, 22 and 0.5 raised to 21, which one is greater?
0.5 raised to 21.
So if number is lying between 0 to 1, so if the number has more index, then the value of that number will be least, right? So here 0.5 raised to 22 will be less than 0.5 less than 0.5 raised to 21. Got it?
Yes, sir.
That's why there will be two cases.
Okay, sir.
Yes. So always there will be two cases. One is between 0 to 1 and second one is 1 to infinity. Next, second part. Again for log, if log of x to the base a is greater than log of y to the same base a, right? So again, there will be two cases. One case is if a is greater than 1, right? If a is greater than 1, then sign of inequality will remain same. While cancelling out log, you will get argument only. So argument will be greater than with the second argument, right? So inequality will remain same if base is greater than 1. Again, if base is lying between 0 to 1, then inequality will get changed, right? So x will be less than 1. This is very, very important for log. You have to keep in mind the inequality will depend upon values of base. That's why you have to consider two cases: when base is greater than 1, when base is between 0 to 1. If in the base any expression is given like x square plus 1, x plus 1, any expression is given, any variable is given, so that you have to consider two cases. Case 1 is base is greater than 1. Case 2 is case is between 0 to 1. Then consider these two inequalities and then solve. You will get some answer. In cases, you have to add the equations, right? Next, suppose let's solve an example, okay? Just quickly, so just taking one example. Log of x to the base 3 greater than log of x square minus 5 to the base 3. Okay, solve this inequality. Solve this. How you are going to solve this inequality? Just this is very simple. Just as you can see, there will be no case because base is greater than 1. So according to first case, so you can just put argument of first log greater than argument of second log. Just solve the inequality. That means x is greater than x square minus 5. Just solve this inequality.
Sir, 1 plus root 21 by 2.
So this is x square minus x minus 5 less than 0. What are the factors?
Sir, 1 plus root 21 by 2.
1 plus minus
Root 21 whole by 2.
Yes, sir.
2 root 5 divided by 2, right?
Root 21, sir.
Root 21.
Okay, yes, 21. Root 21. Right? So inequality is less than
Yes.
0, then x will lie between the roots. So 1 minus root 21 by 2 to 1 plus root 21 by 2. This is the answer. Right?
0, 1 plus final answer.
What?
Final answer is